All right, ladies and gentlemen, welcome to the first video of the Unit 9 notes for Algebra 1. These are dealing with quadratics. This first half is going to be dealing with quadratic, mostly graphs of quadratics, kind of like different components, different properties of the graphs of quadratics, and then kind of the second half of this chapter is going to be kind of solving algebraically, all right? So a lot of kind of the first parts of this video is mostly just going to be vocabulary, so there's not really much to really talk about here. I'll kind of go in more depth when we start actually working the problems out, and all that kind of stuff. So, but just some brief stuff to hit on. This word right here, pronounced parabola. Parabola. Some people call it parabola, but no, it's parabola. The graph of quadratic looks like a U. Vertex, highest, lowest point of the parabola. Axis of symmetry cuts the parabola in half. Y-intercept, well, we've dealt with that before. Solutions and roots, same as the X-intercept, so we've dealt with a lot of this stuff, okay? And again, I'll go into more depth of this stuff when we get there, okay? So now this is a lot of information. So actually, once again, if you need to write this stuff down, pause the video and go ahead and write it down. This right here, finding parts of a graph. So all of this stuff, this is essentially all of the components on how to find the different parts of the quadratic, okay? I'm not going to go too much into these. Again, I will explain as we kind of work out some examples. So again, if you need to write any of these down, pause the video now and we will do that. So, in 3, 2, 1, go ahead and pause. Alrighty, so now let's go and work through, some examples here. Alright, so we'll start with looking at the graphs. Alright, so we're trying to identify all these. So these are all the parts we usually want. We want to see if it opens up or down. Value, which means does it have a max or a min value. We want to see what the vertex is, axis of symmetry, y-intercept, solutions. We want to see all those things, okay? Well, let's go through it. So, first thing, opens up and down in value, all right? These two right here, those are basically connected, all right? Those are kind of, you're looking at the same things. Well, if we look at our parabola, well, the open side is opening up down, all right? So if it looks like this, that means that it opens up facing down. So it opens up down. Now, if we're looking for max or min, we're basically looking at essentially, we're looking at where is the vertex at. So the vertex is right here. Now, is this at a high point or a low point? And if we look, this is at a high point, all right? If it was at a low point, it looks something kind of like down here, all right? So because we're at a high point, we call this a max value. So the value is going to be a max value. So we already know two things without even, having to do a whole lot of math here, okay? So let's find the vertex now. Well, the vertex, again, I pointed out, is this point. It's, again, the highest point on your graph. And if you go from the origin, 1, 2 over, up 1, well, that's just vertex is an ordered pair. 2, 1, all right? Vertex is 2, 1. If we find our axis of symmetry. Now, the axis of symmetry is kind of an imaginary dotted line that goes straight through the middle of your parabola, just like that, okay? The axis of symmetry passes through your vertex, all right? So, it's going to be one of these numbers here, and specifically, the axis of symmetry is always going to be the x value of your vertex. So the way that you're going to write out axis of symmetry, it's going to be x equals x value of our vertex, 2. So our axis of symmetry is just going to be x equals 2 because it's an imaginary line. This x equals, and make sure it's x equals, it's an imaginary line that cuts in the parabola straight in half like that, all right? Y-intercept. We've dealt with y-intercepts before. My y-axis is right here, the one that goes straight up and down. Where does the curve cross? Crosses right here, right at the -3 spot, all right? So my y-intercept is going to be -3. If you want to write out 0, -3, you can do that as well, okay? Solutions, that's essentially kind of the same thing like y-intercepts. Instead of the y-axis, I'm looking at the x-axis. Again, solutions, look for x-intercepts, all right? And if I'm looking here on my x-axis, the curve crosses at 1 and 3. So my solutions are just going to be 1 and 3, okay? So that's the first part. That's the first graph. Let's look at this other graph here. Well, if we look, open side is facing up, so it opens up. And if we look right here, there's kind of a dip right here. It's a low point, so that means it's going to be a minimum value, okay? Now, this graph is kind of weird, so just kind of imagine these check marks in the middle are, 1, so like 1, 3, 5, 7, all that kind of stuff, okay? If you look at your vertex, you go right 2, so the x value is going to be 2, and you go up 2, 1, that's 3, so you're going to go up 3, so the vertex is going to be 2, 3. Axis of symmetry is going to be x equals, what's the x value of our vertex? 2, so it's going to be x equals 2. Y-intercept, where does it cross the y-axis at? If you look, it crosses it right here. That's at 7, all right? It's kind of in between 6 and 8, so I just said 7. You can also write it as 0, 7. Solutions. Crossing the x-axis here. Oh, wait a minute, it's up here. It doesn't cross the x-axis. If it doesn't cross the x-axis, do we have any solutions? The answer is no, all right? You're going to have times like this where it doesn't cross the x-axis. If it crosses the x-axis at any point, you have a solution. But if it doesn't cross the x-axis, you would just write you have no solutions, all right? Just no solutions there, okay? All right, so there's looking at the graphs there. Let's go ahead and go forward here. Let's work out, some stuff algebraically here, okay? So let's identify these indicated parts of this graph, and let's work out these parts here. So y equals 1/2 x squared minus 3x plus 5. Well, let's take a look here. So I got a equals 1/2. Let's just look at let's just fill out the a, b, and c values. Another important step. B minus 3, so it's going to be a negative 3. 5, that's going to be, well, just 5. Opens up or down. I'm looking at my a value. Is my a value positive or is it negative? Look at this first one right here. It's positive. Don't even care what the a value is. All I just care if it's positive or negative. It's positive, so I know it's going to open up. And if it opens up, you know that it's going to kind of have this little dip down here. That's a min value. So if it opens up, it's going to have a min, okay? So I already know what the graph looks like just by looking at that first value. Let's look at the axis of symmetry. Remember, here is my formula for axis of symmetry. Negative b over 2 times a. What I'm going to do, plug in my negative b value. Negative of negative 3 turns into positive 3 over 2 times my a value, which is 1/2. 2 times 1/2 is going to be 1, so I get 3 over 1. Which means that my axis of symmetry is going to be x equals, well, 3 over 1 is just 3. For my vertex, the axis of symmetry, that is the x value. I just plug this into my x value. All right? And to get my y value, well, I'm going to plug this in for all of the x's up here. 1/2 3 squared minus 3 times 3 plus 5. 1/2, do 3 squared, which is 9, minus 3 times 3 is 9, plus 5. That gives me 4.5 minus 9 plus 5. If I get all this stuff worked out, I'm going to get myself 0.5. So my vertex is going to be 3, 0.5. Now for my y-intercept, I'm looking at this c value here. All right? The c value is my y-intercept. That's it. 0, 5. All right, that is all my y-intercept is, just the c value there. All right. So we worked through all that stuff there, and got it all taken care of. All right. So now we got another example here. So let's identify these indicated parts here. So I have a. My a value is negative 4. My b value is going to be 8. My c value is going to be 12. All right. This is also important why you want to make sure your equation is in standard form, all right? Not form, but form, all right? That says standard form, doesn't say. Make sure it's x squared, x, and 12, right? The exponents go in descending order, okay? Opens up or down, all I'm looking at is my A value. I don't even care what number it is. It's negative, so I know it's going to open down, which means if it opens down, it's going to have a high point right here. It's going to look something like this. This high point tells me that I'm going to have a maximum value, all right? So if it opens down, I got a max value. My axis of symmetry, this is my equation right here. X equals negative b over 2a. So let's go ahead and plug that in. Negative b, negative of 8, it turns into negative 8 over 2 times negative 4. Negative 8, 2 times negative 4 is negative 8. So if we simplify that, I get myself negative 8 over 8, which is x equals 1. All right, x equals 1. All right. All right. So vertex, I already know one of those numbers. This value becomes the x value, the 1. All right. Define the y value. I'm going to take this 1, plug it in for all of my x's. So wherever I have an x in my equation up here, I'm going to put a 1. So negative 4 times 1 squared plus 8 times 1 plus 12. 1 squared is 1. That turns into just negative 4 plus 8 plus 12. Negative 4 plus 8 is 4 plus the 12. That gets me 16. So I know my vertex is going to be 116. All right. And then my y-intercept. All you're looking at is your c value. C value is 12. My y-intercept is 12. 0, 12. Okay. All righty. So I'm going to end the first part of 9.1 right there. We will pick it back up in the next video. Thank you.